Good afternoon. It is August 5th, 2015. This is Jason Horak reporting on the ongoing adventures of the Dodge Daytona electric vehicle. What we're looking at here today is the Manzanita PFC-40M charger that I had in my vehicle. I purchased it back in 2010, and it fits kind of behind the rear seat in front of the rear battery box. I had some issues with it. I've killed it on numerous occasions, possibly due to condensation issues, heat, a variety of problems that I managed to kill the poor little charger. It's a very robust unit, and they're actually really sturdy, but I'm kind of accident prone, and these things happen. Just before the convention last year, for the 2014 EVCon, the charger had tripped the breaker and blown something inside that caused it to no longer function. So I kind of took it out of the car and set it aside, and took the spare unit that I have, which is a PFC-50, much larger unit, just so that I could attend the convention and everything would be fine. That charger is really good. I've never managed to kill that, despite putting it through all the rigors that this one has gone through. And I think that largely is due to the bigger airflow inside the case and more hardy components, perhaps, that are just a little larger, older style kind of stuff. It's the workhorse of the Manzanita line. And anyway, so this particular charger, I had originally gotten it pretty much as you see it here, and I had it upgraded during one of its repairs to add the DigiPot right down in here, which is basically a bunch of push button set points for makes a little number go around, and you could set it for the voltage, as opposed to using the Vichet tool, which is essentially a plastic screwdriver in the volts trim hole there for a potentiometer kind of adjustment. What I discovered was that because of just the nature of where I have this charger mounted in my car, it didn't work out really well with the push button controls, because it could get hit fairly easily by anyone plugging in a seat belt into the rear seat, or just me flailing around in the car, moving around packages and so forth. So I requested, when I was sending it back for repairs this time, that they undo that and put it back to the way that it was originally, which basically has the volts trim, recessed trim pot, and you have to use the plastic screwdriver to make the adjustment. The nice thing about that is that then it can't get hit, and it's kind of a set it once and forget it situation. And Rich Rudman, I emailed back and forth with him on this, and he agrees with that position, that that's a better design, and that's why they put it in there to begin with. So I'm happy to have that back the way it was. What I had done was, when I shipped it in October of last year, of 2014, I shipped it in the same container that I've used several other times, which is this one here. And so this is a computer, rugged, tough case that you can ship laptops and things in. And inside, it has a layer of this, foam, solid foam stuff, as well as like a adjustable cutout thing that you can set for your device. So this works that the charger fits in here very nicely, and it's reasonably well protected for shipping. Unfortunately, there isn't a lot of extra room in there, and so it probably doesn't have as much padding as the Manzanita standard packaging method of the cardboard with some solid foam and stuff. So when I got it back on its return trip from Washington, it got broken. The breaker switch here on the right hand side, it probably isn't making it on the camera really well, but it's the little plastic here had broken. So I could probably do like a super glue or something to try to fix that, but because it's a component that is very vital to my car, I really didn't want just a super glued up piece. So I searched online to see if I could find a replacement breaker, and what I found on I think Allied Electronics was this unit, which is the same model that's in there. which is a Carling Technologies. It's a 40 amp breaker, and it trips at 54 amps, and it's a 34, I think it's a 34 volt, is how that works. So on the bottom it has 34-40A. But anyway, this is identical to this unit as far as like the part numbers and stuff. So I ordered it from them. It was about $60, and I'm going to put that in the charger to replace that. What I noticed was that while I had the cover off, I'll go ahead and take the cover off here and show you, and was looking at how to get the breaker panel out, I looked over on this side and I noticed, let's go ahead and set this over here, that this little component here, this white unit, it's just kind of hanging there, doesn't seem to be attached. And let's go take the camera in for a little closer look. I'll turn on the loud, obnoxious light here as well, just to kind of help see it. So it looks like what happened was that during shipping, the solder point here broke loose, and this component is now no longer connected. Did a little research online for this component, and it appears to be a snubber, I believe, capacitor, and so I couldn't find the exact model of that. So what I'm going to try to do is repair that that solder joint by removing the one that's holding it on there, to pull this component out, kind of clean up the connection, and then very carefully resolder it back up on there. And I'm going to use some kind of adhesive to help hold this to the bottom of the board, some non-conductive adhesive, just to give it so it's not just hanging on those little tiny wires that are coming out of the capacitor. So anyway, that's kind of my master plan there. I don't know how well it's going to work. I'll probably just ruin the whole thing and have to buy a new charger, but at least I can give it a try. Worst case, I'm hoping my buddies at Manzanita Micro will bail me out and do the repair for me again. I just didn't want to have to ship it back to the other side of the country, because I think it's the shipping that's causing half the damage on this poor little thing. So anyway, that's kind of where we're at now, and I'm going to try doing the soldering, and I guess we'll see how that works. Well, we've been struggling with the charger desoldering and resoldering project for about a week now. My friend Kevin Cappy assisted me with helping to remove this component here to desolder the two little leads up there, the one that was broken as well as the one that was still attached. So we got that taken out, and then I put a couple extension leads on there, soldered them on, and then soldered them to the main board. However, I had a lot of trouble with getting the solder to stick, and just basically my solder gun was not up to the challenge, my little 60-watt soldering iron. So my friend Kevin Whitlock kindly provided me with his Radio Shack 230 to 150 watt soldering gun that just did the job. They got the stuff melted, and I was able to get in there and both remove the old solder as well as get new solder in there. Now, let me see if I can bring the camera in a little closer for a look here. Alright, so this is the component, and as you can see, I've extended the leads, and I know the camera is having trouble focusing, but basically there's a little bit of solder that holds these leads on here, and I bent the leads around so that it would kind of be hanging like a hook on those two extensions, and then I also took this item and I glued it to this back surface with the special black gasket sealant stuff that's good for up to 750 degrees Fahrenheit or some such thing. So anyway, this particular unit is now really solid in here. I can lift the whole charger by just the glue, so there's no pressure hanging on these two pins anymore. on top, you can see that my solder is not the cleanest work ever, but did what I can. Again, the camera is not focusing at all, but you can kind of get the idea that it's in here, it's super solid, and it's connected as best as I can. So I have not plugged in the charger yet. I've been kind of scared, to be honest, but I'm going to go ahead and put it back together, at least put the cover on for safety, and then I will put it in the car and we'll see if it shoots smoke out or not. Fun, fun, fun. Okay, now we have the Manzanita PFC-40M out in the garage, ready to give it a test. After my stellar soldering job, I'm a little bit nervous as to what it's going to do. So we've got it out here to do a test on a 12-volt battery prior to putting it in the car and seeing the smoke come out in the car. I guess it's better to have it in the garage. Anyway, just as a review, I had not plugged in this charger at all because the breaker switch that was on it when it came back from Manzanita was broken. And as you can see in the better lighting now in the garage, it's just busted. Now you can kind of flick it a few times. If you get it just right, you can kind of get it to stay on, but it's just one of those things that I really didn't want to have in my car, you know, because I just sort of plug in this charger and walk away. It seemed like a bad idea to have a switch breaker in it that was kind of defective to start with. So anyway, I bought a new one, got it installed in there, wired up. It was relatively straightforward, and hopefully will just work. So as far as the test goes, I have the Manzanita plugged in with, these are my standard 120 amp capable Anderson connectors, positive and negative. And then I've got a little adapter here that goes to the standard Anderson 40 amp connector that comes on the Manzanita. This is the one that I send back to Manzanita whenever I have it repaired, just so they can plug it in and do testing and that kind of thing, without having to have my particular setup. Anyway, this is just plugged into a Metropolitan Industries 12-volt battery. This is the same, or one of the batteries that was in my original electric vehicle. And I've got a multimeter here to test the voltage before we start, just to kind of show where we're at the beginning. So let's see, positive and negative. So we're at 12.65 volts on the battery. 12.7 volts, depending on where I happen to touch the terminals. Well, 12.70, we'll say. So it's fairly charged already. I didn't want to start with a battery that was completely depleted, just because we want to give this charger the best chance it can to not blow up and so forth. So we have the amp knob turned all the way to the left, all the way down at no amps. Breaker panel is off. All of the dip switches are set to the defaults, which, just as a review, it's 1 is on, 2 is off, 3 and 4 are on, and the rest are off. I haven't changed anything with the timer adjust or the volt trim at this point because I haven't turned it on. And so I do have my Vichy tool ready to go to make the voltage adjustments, but of course I won't really be adjusting it for this 12-volt battery. I'm just doing it as a test to make sure that it works in concept, and then I'll put it in the car and we'll do a voltage adjustment for the battery pack in the car. So, alright, I'm going to go ahead and get this plugged in. I'm going to leave the camera running just in case the smoke pours out before I even turn the thing on. Here we go. So far so good. We're plugged into the wall and no fire. So here we go. We're going to go ahead and make sure once again the amp knob is at nothing. We're going to flip on the breaker. Alright, good. Standard light. We got a green power light. 0.4 amp draw, which is pretty normal. I think that's sort of registering what it takes to run the charger, just the fans and so forth, when it's not actually pushing any current into the battery. Now we're going to try very slightly turning up the amp knob just to see what happens. Alright, so we're going up in amps, that's pretty good. 5 amps, seems to be capped out at 5. It might be detecting that the battery is charged, or it's getting enough resistance back from the cell that it's not sending any more in. I'm not sure why it doesn't go above 5, but that might just be an indication. Technically, yeah, that's probably right, because we're taking 220 volts coming in from the wall, and we're dumping however many amps we can into this 12 volt battery, 12.8 volt thing. Actually, while we're at it, why don't we go ahead and put the voltmeter back on here, and we'll take a look at what's happening with that voltage while we're putting some amps in. So I do this, see if I can get this to stay here without supervision. Oh, that's not going to work. And due to the magic of video editing, I was able to loosen these slightly and then put the leads in there so they get a good connection. So we're showing 13.6, so it brought it up from 12.7 to 13.06 just by virtue of that very quick charge. Probably we're putting in a lot of amps. We're going to just hit this real gentle like. There you go, 16 volts. And back off on it and let it drop down. So this is actually working great. This charger works like a champ, even with my super sketchy soldering job. So yay, go team! I'm going to go ahead and get the charger fully put back together. I have the cover on but not screwed in, so I'll get all the screws put back in, and then we'll stick her in the car and we'll try it again. This is just a quick follow-up to that earlier video. I was able to find I had another Metropolitan Industries Power Plus battery that wasn't fully charged. And so I have one here. It's at 11.1 volts right now. It's actually dropping a little bit because I was playing with it on the charger a second ago, but basically 11.1-ish. Turning on the charger, you see that the voltage immediately jumps up on that battery. I'm not sure how well the camera's making it out, but it shows 13.7 volts right now. And so that's just where I adjusted the amp knob to bring it into about that. So at this point it's actually charging that battery, and at about the same rate as an alternator would. It's pulling 0.8 volts from the wall at 220 volts. Sorry, it's 0.8 amps rather from the wall, 220 volts. I don't really have a way of measuring how many amps are going into the cell with this particular setup, but I just thought it was kind of cool that we could actually charge the battery and demonstrate that the charger is in fact working the way it should. So fun stuff. I'm going to go ahead and put it in the car and we'll go from there. Okay, with the charger repaired and now reinstalled in the car, and the extra battery, the one up front that had been damaged, removed, so we're now down to 59 cells from the 60 we had before. We now need to reconfigure the charger buddy as well as the charger to reflect the new voltage that the pack is during charging, when the charge terminates, and then where it settles back to after it's finished. And as you may recall from the earlier video, all of this is controlled by the charger buddy's little voltmeter here. And by virtue of the relay that is lit up here with this little LED is indicating that the relay is on, that is what allows the power to flow through the cable into the charger and power it. So right now we're at 195.3 volts. That is the middle charged resting voltage of the pack at this point. It's fairly well charged, but not completely. So what we're going to do is reconfigure this. Flip the little door open. We have 4 buttons. One that's kind of like an enter, a right arrow, and a down arrow, and an up arrow. And that's all you need, or all you have available to charge or to configure this little voltmeter. So what we're going to do is, first things first, we're going to hit the enter to get us into the programming mode. We're going to arrow over, right arrow over to the last digit. We're going to set that to a 1. 1 is just the one we're looking at changing configuration on today, and then you're going to hit enter. So this gives us our menu for programming the relay set points, so that the upper and the lower values. So the H1 is the high value where the relay trips. L1 is the lower value of where the first relay trips. H2 is the high value for relay 2, and L2 is the other set point for relay 2. And then end will get us back out of the menu. So that's all we have in this menu. It's relatively straightforward. So what we're going to do is go into the first AH1, and right now you can see it's set to 200 volts. So what this is when the pack has been fully charged to a certain point, it's going to fall back and settle at this value, and this is the value that kind of like determines when the charger kicks back on again. So it's the fully charged indicator, basically. When the pack hits this value, that's when the charger will if it goes below this value, that's when the charger will turn back on, and then it'll charge up to the other value, the AL1, and then drop off. It's just kind of how I have the relays configured. It's a little bit convoluted and backwards, but it works quite well. Anyway, so this value used to be 200 volts with 60 cells. So let's do some quick math here just to review. So if we have our 200 volts divided by our 60 cells, we have a resting voltage of 3.333 repeating volts per cell, and that's basically where these cells settle out to when they have been given a chance to rest. At fully charged 3.3 volts, we're calling it good. That's a little bit undercharged from what the specification states. The specification states 3.4 volts per cell, but you know, we're being kind to them and undercharging them a bit. So that's how we do this. So our new voltage that we're going to want is basically the 3.33 repeating times 59 cells. So that gives our 196.6 as our fully charged resting voltage. So we're going to go ahead in here, and it timed out on me while I was babbling, but back to number 1, AH1 again, 200, so we're going to change that to a 1, and a 9, which I could have gone the other way, but you know, and a 6, 0.6. So that is now our resting voltage, where anything below that the charger will be on, and it will be on again if it goes below that value from while charging. So now we're going to go to L1. So now this one was previously 210 volts. So 210 volts was where we had it set so that the charger would come up to that point, and that's where we terminated our charge. So we're going to divide that by our 60 cells. So we had 3.5 volts per cell. That's what we were charging up to as a max. Again, the specifications state 3.6 volts as the voltage to have well charging. So this is while the charger is pumping in 40 amps. 3.5 volts is where we settle, so, or where we terminate the charge. So what we're going to do is actually change that to, and again we've got to do the math here. It always comes down to the math, doesn't it? So 3.5 volts per cell, so times 59 cells, we're at 206.5. So just keeping all the numbers the same, this would be a 206.5 Okay, so now our AL1 is set to 206.5. So that is now where the charger will terminate automatically, and it'll fall. It'll allow the batteries to settle down to the AH1 value of 196.6. And that's kind of the only one we're going to change. We're going to leave the other two alone, but just to review, the AH2 is set to 50 volts. So anything below 50 volts, it will trip that other relay. And L2, 100, anything over 100 volts will make sure that relay is off. So that's just kind of like a little bit of a slop range that I've allowed in there for when the pack is turned off via the maintenance disconnect. And to end it, we're just going to hit end and then enter, and we are done with our configuration. So the reason for that, of course, is that if you shut off the maintenance disconnect in the front of the car, the voltage is going to drop from wherever it is down to 0 in pretty rapid fashion. Depending on how much load is on it, it'll be either instantaneous or it takes a few minutes for the surface charge to kind of bleed off of those terminals. So that's why there's that slop in there of 50 to 100 volts. Basically anything under 100, it's going to shut off, or it's going to actually turn on the secondary relay, the bottom one there, the little light will come on, and that just means that it will disconnect the charger if the main pack is turned off, basically, and it's going to try to protect the charger a little bit, because the Manzanitas are, it says in the manual that if there's no load applied to it and you power up the charger and try to dump 40 amps into the air, it's going to damage the charger. So I'm just trying to protect it as much as I can. Anyway, so that's it for the configuration, the reconfiguration of the Charger Buddy. And all we're going to do is turn on the charger. Let's turn that a little bit. So we turn on the charger. I'm not sure if the camera is making that out, but we're pulling 36 looks like 8 amps from the wall. And according to my JLD 404, we're putting in between 35 and 40 amps. Kind of fluctuates up and down with that. And we're charging. You can see on the Charger Buddy. 198.5 and rising. And of course the charge is going to get really loud here in a second, because it's a smaller charger with a big fan to try to keep it cool. But anyway, we are happily charging, and I may check back as we get closer to the end of the charge here, just to show you the charger shutting off. Okay, so we're coming up on the end of the charge process. As you can hear, the charger is very loud, so I'll try to talk over it so you can hear me. Anyway, I just wanted to show you how I adjusted the volts trim. See how the little light just came on here? So this is the timer light and the limits light, showing that we were close to the end of the set point. Also, you may have noticed that the voltmeter had hit the 206.5 before it just turned off and made things nice and quiet again. Anyway, so I've got it calibrated so that it's very close. The charger starts to limit the current pulling from the wall and going into the pack right when it hits that 206.5, I believe was what we set it to. And so that's just with this plastic Vichet tool, you do that little adjustment, and that's how you get it to be dialed into a particular voltage. So the reason why they're fairly close is that if, for whatever reason, the Charger Buddy should fail and stay on, then the electronics in this nice, expensive, quality charger would take over and make sure that it limits that power going into the battery pack to the 206 volts. And now the charger will hold it there, and it goes into a constant voltage phase, so it stays at 206 and just keeps pumping in, or lowering the current down, and to maintain that that 206. However, with the Charger Buddy, as soon as it hits that point, it just shuts it off, and calls it a day. Says, hey, we've got enough charge in there. So again, we're undercharging the pack and not pumping in every electron that we possibly can. But I'm okay with that. I'm okay with not charging the batteries fully. Although, there's always a chance that I'll run out of power before I get home if I didn't calculate things properly, which has happened and will likely happen again. But anyway, so we've got the pack fully charged at this point, and the charger is off. The Charger Buddy is monitoring as the batteries settle, and if it got down to 196.5, I believe we set it to, then it would turn the charger back on for a little bit. It would bring the charge back up to 206 and terminate it. The nature of these batteries is they take a long time to settle. It'll probably be 12 hours or more before they even hit that point. So if you left the car chart plugged in, the Charger Buddy would basically maintain that, keeping them topped off by cycling the charger on once every 12 hours or 24 hours or whatever it takes, putting a little power back into them and then shut it off. So anyway, it's an interesting setup. It seems to work pretty well for me. I don't know, your mileage may vary, as it were, but that is the full deal. And so the charger does seem to be working. It does get very loud. This particular charger, being such a small container, it has to move a lot of air through it to keep it cool, and it's notably louder than the PFC-50 that I have. But it's alright. As long as it keeps working, I'll be happy, and it does fit nicely behind the rear seat in this configuration. So that works out better for my cargo area and that kind of thing, and that I don't have the charger taking up an excessive amount of space in the trunk. So anyway, that's it for today. Have a wonderful afternoon, and I will catch up with you all later.